Hello to viewers, welcome to my channel Science to Technology. In today's show, Science Thursday, we're going to talk about high-speed rail, HSR. So let's dive right into it. Now, what exactly we are talking about? We are talking about basically something a bit faster than traditional rail. Traditional rail is generally something that is traveling slower than 150 kilometer per hour or around 100 miles per hour, something like that. Now, if you go surpass that significantly enough, then that's what we are talking about. So if you have a pre-existing railway infrastructure, like let's say India has Indian Railways infrastructure, if you want to classify that as high speed, it has to have things that are running on it that is above 200 kilometer per hour. Now, be mindful when we are talking about this sort of speed, it's not supposed to be peak speed, because like TGV could have like ludicrously weird peak speed where it has almost touched 600. It's like, yeah, it's above 500. They can do that. Even Shinkansen, they can achieve 600, but here's the deal, they will not drive it at that speed. So there is a generally good balance between speed and power consumption. So you will try to be like in reasonable scenario. So reasonable scenario could be around, depending on your demand, you could be like, hey, traveling at 300 kilometer per hour or 350 kilometer per hour or 400 kilometer per hour. But generally, it will not try to achieve supersonic. And not to mention, there is also noise pollution, because you will go through places where people are be there. If you are taking a giant chunk and just whoosh, at 400 kilometers, that's enough noise pollution that it will hurt people. So that's why the classification is around 200 kilometer per hour for upgraded system, meaning if you're taking existing track and you're just polishing it to accept high speed, 200. If you want to create a dedicated system like Japan did, that's 250. That's what you're supposed to do. And it's a complete ecosystem of train, because it's not supposed to mix with anything else. It's not supposed to do anything else other than ferry things or people as fast as possible. Generally, because of the cost of it, is generally does not viable to do high speed coal delivery. But you can do that. Like there are companies in China that are doing parcels using this sort of train, high speed train, and it's very fast. So that's what we are talking about here. So why do we have such a need? Well, need is, well, realistically speaking, if you are traveling far, or if you are in a huge country like USA, which is 3 times larger than India, or like China is also bigger. So in those sort of scenario, plane makes more sense. Specifically, if you cross 400 kilometer plus, the moment you cross that distance, it creates a paradox. Because, for example, let's say there is a new airport opened recently. That airport is next to Kolkata. Kolkata is a major hub. Now people want to go there from this place to Kolkata. Now it's a 6-hour train journey. That means 7 plus hour you have to take from traveling from your house to railway station to train to getting where you need to go in Calcutta. But when the moment you compare it to, let's say, aircraft, you may say, oh, that's only 1.5 hours. But here's the deal: the check-in and check-out, that adds enough time where it's no longer like black and white win. At that point in time, it's like maybe not worth it, because again, cost also plays into it. So in those sort of distances, not. But again, let's say compared to this X place to Delhi, and let's say that takes around 18 hours of travel time in by rail, and then it takes 2.5 hour travel time by aircraft, then it's a no big deal. At that point, even the time that you require on the front end and on the back end, basically check in and check out, is still viable, still cost effective, time effective. So people will do that. So there is a sweet spot. That sweet spot is calculated to be around 400 kilometer less. If you're talking about around 400 kilometer less, then high speed train makes sense. And if you're like, okay, Narendra Modi has recently launched a lot of small airports. There are some big airports in like every major capital city, but after, like, every state has a capital, every capital has an airport. Then there are also auxiliary systems. In those auxiliary places, they are creating a lot of new airports. Those places are also getting airports. So in those sort of scenario, like, wouldn't investing in aircraft system would be more efficient than high speed train? Well, here's the problem with that: you can have aircraft, you can have GG amounts, but here's the price is controlled by someone else. Like, what does that mean? That simply means if Putin decides to go boom, that creates a price crisis. If Saudi Arabia starts to go boom, that creates a price crisis. That's a very serious scenario. From a national point of view, you do not want to be dependent on someone else. Now that's just the price part. Assuming people do not become dumb, they could do something wiser. They could be like, let's do seaweed, algae, biofuel farming, and then be like, okay, that's the only replacement that is carbon neutral and works with jet fuel. Do not require to change anything. And India has enough sea border that they're like, bro, we don't even touch international water. We just touch our national water, and we don't even touch international. We are done. We're good. We can supply enough. That will take care of your fuel prices. Not viable for every country, but enough. It is viable. But what can you do about weather? There are scenarios, even if you have every small airport equipped with the latest and greatest radar technology, latest and greatest homing technology, there would be a time where weather is like, thou shall not land. And aircraft pilots are trained on one thing: thou shall return home safely, because there is no ejection seat. They must return home safely. So in those sort of scenarios, weather could also play a role. And if you live in a places where there are extremely bad weather extremely regularly, you'll be like, dude, that's not good enough. You cannot have something as critical as infrastructure there's a downtime as high as every once or twice a week. So these two creates a scenario where there is a gap. There is a gap in supply, and there is a demand. High-speed train takes care of that. Now, from an economic point of view or carbon footprint point of view, it's also very efficient in terms of kilometer per hour, as in like your speed and distance covered. You will find trains are far more energy efficient. Like, it's so efficient that if you take a train, because trains have like steel wheels on steel system, the rolling resistance is very low, and because there's giant stuck object that is traveling rather than multiple small objects, the wind vortex, even on a poorly optimized system, it's so efficient that you will think, oh, it's taking 6,000 horsepower to pull that many people. Yes, try to do that with on cars. Even if every car is filled with 4 people, you will be surprised how much horsepower you need just to move that many people. And not to mention, it will be much slower, and not to mention the footprint would be wider. So train is efficient. And from a country's point of view, let's say why Japan burnt so much money into investing into bullet. They knew for a fact that they do not control their fuel prices, and weather is a serious thing, especially if you are that close to the sea. They are like, high-speed train makes a sense, because again, they can control their coal system. France can control their nuclear power plants. So at that point in time, it's like, dude, we got it. It's our under control. Now, what does the benefit you have to the civilian population? The increased range of daily worker, that's the biggest thing. Because let's assume you are in Delhi and you are next to it, let's say Noida. You can have a plane that takes you from A to B, but here's the deal. What is the probability that a daily worker can A, afford it, B, would willing to do all the time required to do this sort of thing for daily jobs? Nobody's gonna do that. That's the whole point. Nobody's gonna do this for daily commute. One or so while, that's good. Daily, hell no. Now, train people do use this sort of scenario for daily commutes, and it's a common trait. Like in India, in Japan, everywhere, people travel to different places utilizing train. Now, if you increase the train speed, the radius, how far a person, let's say from a small village, can travel, that grows up exponentially. So you could have a scenario where, like, even in Bangalore, when I used to stay there, I used to travel around 1 hour. Now, 1 hour, let's say that translates to 15 minutes going to station, 15 minutes coming from the station to my office. That gives me 45 minutes of travel time. That's enough for high-speed train, that if you are traveling far enough, that's like almost in a different city or a different suburb. So it increases the range of daily work, and that's why it's so popular with Japan. They could have a scenario where it's like everybody is working in Tokyo, but they are living nearby district towns or things of that nature, where using train. Unless you have to be rich, because again, high-speed train is expensive, not as expensive as this, much faster compared to this, especially in 400 kilometers. So you could have a scenario where like a lot of people are just like, hey, I work in Tokyo, but it's too noisy, I do not want to stay there, the housing prices are stupid, so I just travel here. So it is a really good GDP booster. It's awesome for everyone. Then it also creates a stable infrastructure for long term. Again, airports are vulnerable to other things, and remove that also. From a country's point of view, if you are collecting taxes, you have to invest it. You cannot just like, I'm collecting taxes. You have to do something with it. So investing in infrastructure is really wise, specifically infrastructure that lasts a very long time. Yes, you have to maintain it. Yes, you have to train pilots on it. You have to do a lot of things. But overall, from a long duration point of view, Japan gained exponential gains out of it. So that's why they are investing even better versions of it. And so did France. So did Germany. So everybody is pouring their money into it, because it's a long-term project. It will not give you return instantly. Don't even expect that. Airports have quicker return comparatively, but over time, it's like GDP boost. Now, nations invest in this sort of system during recession. That's why China literally went from having nothing in 2008. After the financial crisis, they're like, okay, way too many people are in jobless. So what if we create projects, giant national projects, creating high-speed railway? People are employed. That employment creates secondary employment, because food, steel, all that jazz creates secondary, boosts the economy, stabilizes us against recession. And then once it's done, when people go back to normal jobs, we have a structure that will boost our economy. So it's a good system. And that's why Hoover Dam was built, literally to get people out of recession. And it does work. This sort of system is good. It's just that why the heck USA did not do that, other countries did not? Red tape and bureaucracy. China does not have bureaucracy, does not have people's voice. So if they're like, your house is here, I want to run a high-speed train there, yeah, high speed will be there. Whatever happened to that person, it disappeared out of the map. Things happen, people disappear. So that's why there is a need for it, specifically for under 400 kilometers. So let's understand the technical sides of it. Rolling stock, basically anything that moves in this. Now, it has to be lighter as lighter as possible. Now, that is counterintuitive in railway terms, simply because railways have to be as heavy as possible, otherwise the wheels will slip. Now, not too heavy, but heavy enough. So you could have a scenario where if you ever watched making of any electric locomotive, they will put literal metal ballast weight on it just to make sure that it does not slip, because again, diesel locomotives are inherently heavy enough where they're like, we good, we got this. Electric locomotive is not that heavy, because instead of a giant ass generator, all they have is a giant ass transformer. So it does require metal ballast weight, otherwise it will slip too much. So then you will like, why the heck we have to make it lighter? Well, if you do not make it light, you will not be able to press the accelerator, no matter how hard the driver is going ding ding, trying to accelerate it, it will not accelerate. It will just, inertia will stop you. And let's say once you did pick up the speed over time, let's say instead of picking up in, let's say 10 minutes, you pick up after 35 minutes, if you apply brakes, good luck, your brakes will go poof. It's not going to do anything, like literally it will not stop. That's why whenever you look at high speed cars or supercars or hypercars, they are trying to be as light as possible. And that's the two reasons. Your acceleration also improves, which everybody understands. So does your braking, meaning if you apply brakes, your brake can like, I got this, fam. And in electric locomotive, it does have an advantage where you can do regenerative braking, so your brakes last exponentially longer, because brakes wear out worst from like, let's say 250 km to 100 km per hour. But if you can do regenerative braking, which is its sweet spot, it's good. Now, aerodynamics becomes very important at high speed. It's not a big deal in Indian Railway, because most of the Indian Railway, majority of the time, is running below 150 kmph. Now, does aerodynamics play a role? Yes. But does it play enough role to justify the expenditure? No. That's why we don't have aerodynamic trains. But the moment you start to travel at high speed, 200 plus, it makes sense. At that point in time, yeah, it's worth it to spend the money to have a chassis that is like very smooth. So it does work. Now, how do we achieve this kind of speed? Well, you achieve it with multiple power units, meaning you let go of the old architecture of having giant locomotive in front. You will have multiple locomotives, as in like motors, in each of the bogies. This puppy is the bogie, the things that you sit inside that are classified as coach. So this is the bogie. So this bogie will have motors. Generally, they will use synchronous motors to achieve really good efficiency and high speed. So multiple of this will be used. Now, depending on design, you could have 3 units. You can have every other bogie could have motor, or really hyper speed, every bogie will have a motor. So basically, almost all wheel is like, train will be like all wheel drive. So benefit, super high acceleration and super high deceleration. Again, regenerative braking. So that's a desirable, and that was a compulsory requirement for a Japanese system, because they had stops very close to each other. So they did not have the time that German places had or France had, where the like train will take up time to accelerate, then it will take up time to decelerate, and then it will have a time in between where it's at high speed. Japan was like, nah bro, go at 1G if you can do it. Again, they do not go at 1G, but they can do it. Trains are that capable. Now, everything is fine and dandy at this point in time. However, there is a virus at 200 kmph plus. That's why classified as hunting oscillation. The moment you take this sort of bogies and you start to spin them up very quickly, you can have the best wheel, meaning even on a microscope, the wheel could be like perfectly round. You can have perfect tracks that are perfectly, stable, flat, everything is awesome, but it will start to dance no matter what. It will like this is what we call hunting oscillation. And this was the limitation, but that's why people very early on, like as in 1950s, did not take high speed very seriously, because this was unsolvable. So somebody figured out, what if we use brute force to solve it, like having yaw oscillator dampeners to solve it. It did work, and that's why we have trains that exceed 300 km per hour, because otherwise this puppy will just dance your wheel out of it. It's a very weird thing. You will think it's happening because of something else. No, it's just an inherent principle of metal mass spinning at this speed. So it has to have dampener, and some trains have active dampeners where they are like observing the oscillation and then compensating for it. So that's the thing. Now, if you take a high-speed train, you will think like the locomotive, the pantograph and all that, those will be expensive. Nah, the most expensive part is this system. This is the basically, if this is a $20 million train, where has 15 million went into it, 15 million went here. That's the expensive part. Everything else is cheap, comparatively speaking. So bogies are the most expensive part. And here's the deal. If you take the whole high-speed railway project, this system, rolling stock, that's the cheap part. That's the easy part. That's so cheap, comparatively speaking, that it would be like, dude, we let the interns do the mathematics on it, because that's how cheap it is. Then we come to the expensive part. India recently got this high-speed train system, supposed to be capable, again, it inherently is capable of 220 km per hour, should be traveling at around 180 km per hour. But like people got this impression that, this is the big thing. Here's the deal, that's the cheap part. Expensive part is the thing that is riding on, the tracks, basically. Now, why is that? Well, same way there are rules in reality, that there are 3 rules: physics, engineering, economics. So physics has some rules here. That is its own constraint, meaning if you are having a train and you want to go at ludicrous speed, as in like 400, You cannot have track that looks like this. Track is best suited for 300. The moment you start to touch 400 on this, it becomes unstable, meaning you can literally derail out of lol. It's just like that could happen. So be mindful. And that's why even if you see things like high-speed train in China or Japan, you will find that the track curves are very gentle. It has to. Otherwise, they have to slow down every curve. So at that point in time, it's like, what's the use? UK did try to tackle this because track bend is a very serious issue in UK because, again, their railway network is very old, as in like ludicrously old. In those sort of scenario, you cannot just like, remove all the old tracks, create a new tracks and destroy cities, villages and all that just so you can have speed. So they created a scenario where train will tilt almost like a biker to make curves at very high speed. It does work to some extent, but does not work at very high speed. So that's why you will not hear about like British train traveling at like 400 km/h. And slope is nothing can be done. Now that's a really bad situation for India because India has a lot of slopes. Again, India is a plateau region, so our tracks are like this. Now, tracks itself must be super stiff and flat. Flat means meaning you should be able to take a dial gauge and run across it. It should be that flat over the distance. It cannot be, oh, this part is flat now. It has to be smooth and it has to be very stiff because track does create a very serious oscillation because loading and unloading will happen in fraction of a second because your wheels, if that's like 50 km/h, okay, that's slow enough. But imagine that 300 km, that's like literally, it's almost acting like a spring at that point. So it has to be very high stiffness. Many times for high speed track, they're like, don't even put ballast there. They are like, just put concrete there. It's far more longer lasting. Again, expensive, but longer lasting. And it does have a bit higher stiffness. So people prefer that. Continuous welded rail has to be used. If you try with fish plate, either your rail will be destroyed or your train will derail. So you have to use continuous welded rail. No grade crossing and intermixing. This is the critical aspect. That's why everybody says Japan was the first country to do it, because that's the part they figured out. Every country, be it UK, be it USA, be it Germany, be it France, everybody tried high-speed train. But everybody has like, we'll have express train on the same track as the non-express one. But everybody realized very early on, if you have a train that is traveling at high speed, the braking distance is exponentially longer. You have to give enough space there. You cannot give space there, oh, if there is a slow track, train on the same track. You cannot do that. Fundamentally, you cannot. You cannot have grade crossings. That's a very brutal scenario. Grade crossing tracks, roads. You cannot have this. It has to be like this or like this. It cannot be like this. They cannot touch. Japan really spent boatload of money into achieving this. Now, again, Japan is a very small population country. Again, I'm saying from India's point of view. So I have to remove billion plus people in India, then you will get the idea how small Japan is. So that's the whole point. Grade crossing, depending on your country, depending on your population density, could be super easy to achieve, could be very difficult to achieve. In India, it would be almost impossible to achieve. Intermixing, does require some elbow grease, but can be done. Now, there is a very severe danger, specifically in economic layer. Like physics is there, engineering is the part that we have sorted, but there is some serious economical hurdles here. That's a serious danger. The danger comes from it's hyper expensive per kilometer, meaning if you take a normal railway track, that again is expensive. That's, you are talking about bare minimum $5 million per kilometer. Yeah, that's how expensive we are talking about here. So assuming you can afford that, that's good. How expensive you think would be high speed? 10? No. If you're doing with European standard, you are talking at least 20 to 25 million dollar. If you're talking to Chinese standard, which trust me, for longevity's sake, you do not want to do that. That's around 12 to 25 million dollars. So that's still very expensive. So that's the whole problem. Now, it creates a debt trap, meaning if you have low ridership, because you will always notice trains are of a specific size. Now, that size is decided by how much money it takes to run that system and how many tickets we can sell. So if they are like, it takes X amount, they will not make X minus. They will always make sure X plus. So you will have, let's say, a train could easily have 500 seats. They're gonna sell, assuming that they sell even 90% of it, they should be able to run in positive. Now, like, isn't there public owned system, meaning tax based? No, they're not. They're still normal projects like a tax system, meaning tax is just a bank balance that they are utilizing. They have to run the system, meaning if they are not running it in profit, they have to borrow money in order to do maintenance. So ideally, every country is like, okay, we're gonna build it. Hopefully the system would be profitable enough where they are like slowly paying off the loan. Again, it will be very long term, like as in like 100 years long term, but it will provide enough money that maintenance, upgrades, all the staff payment, or at least that it should not run in negative constantly. Again, little bit of like minus 1%, 2% acceptable. Minus 30, 40%, yeah, you did. So that's a very serious scenario. So you cannot have low ridership. If you're talking about making a Japanese train and that's like super awesome, super amazing, it has to have all the seats filled up. Otherwise, it's created a debt trap. China did create high-speed railway network, but it went hyper stupid with it, meaning they put it everywhere they could. Now, this is a map of India with population density plotted out with the brightness. So if you pick a high-speed railway from here to here, awesome. If you put high-speed railway from this hotspot to this hotspot, awesome. You put somewhere middle of here to middle of here, nothing. You're gonna have a debt trap at that point in time, or technical term is white elephant. So it creates a scenario because you have to create a scenario where train is profitable below the aircraft ticket, because if here to here is the airport, people will choose airport if the aeroplane is cheaper, because you cannot travel fast as like 630 kilometer per hour. You know, just know. So fundamentally speaking, that creates a scenario where you have to study geography and demography, and that's the reason why UK is so behind in this system, because their geography does not. India also does not have good geography. We have like a lot of undulations, and demography, again, most of the concentration is in this area. So if you try to cover the whole India, you will create a scenario where you created a debt trap, like how China did. China had like majority of the population focused around the coastal area, and then somehow they have like a high-speed railway network deep in the land. It's like, how? Why? Nobody is there to use it. Yeah, and that's the whole point. Train running on those sort of places, it's empty. Now that's like, country can afford it. Nah. No, not really. That's the whole thing. Low ridership means a debt trap in this sort of scenario, and it is so expensive to maintain compared to normal locomotives, compared to normal railway system. It's exponentially destructive. You have to make sure that there is enough ridership, otherwise it goes bankrupt. And like how risky China's situation is, $900 billion debt to $2 trillion debt. That's how bad it is. So, and that's why people were like a bit shocked. Just like, how the heck China does not have population, does not have enough people that can afford their high-speed tickets. And now they're like, yeah, we cannot increase the ticket price because it is almost touching aircraft tickets. That's the whole problem. That's why it's not something that like, let's give high speed to everyone. It would be a really bad scenario. So it may not allow cost-effective use, and you have to pay it back. That's why every time people are talking like a railway should be like free for public. Not really. It has to make money. Otherwise, A, you will not know how people are using it. B, running cost will be exponential. So imagine Indian Railway. Again, if you have ever lived in India, we are very populated country. Like most people don't have context of it. They think USA is populated. Yeah, it is third population. How small that is? Remove 1 billion from here, the remainder still would be larger than USA population. That's how big India is. So in India, saying like having zero railway crossing, very difficult. That's why there is a high-speed railway track being built here, bullet train track here, from the loan from Japan. Problem is, it was so difficult to do, like basically zero grade crossing. They're like, everything is elevated. They're not even trying to make it on the road. They're like, just elevate it, just put it on pillars. Again, you can understand that will increase your cost exponentially, but there was no other option. So that's why it may not be suited for India. Now, this is the photos I have taken when like a few years ago. This was the speedometer in the coaches, 109 kilometer per hour. It did touch 120, but I could not snap it at that time, so it did drop. So, and you can, even the old coaches will have this rating, 160. Modern coaches have rating of 220. But given the fact that we do not have track infrastructure that is strong enough to endure it, we are stuck. So it would be far more efficient use of funds to just make every track as robust as possible and make sure we can touch this speed. Again, India has two core sets of bogies, IFC bogies and LF. I forgot LHB, some German design systems that is capable of 220. So we can do that as long as we can keep upgrading the tracks. Tracks is our bottleneck. We don't inherently need, like, it will barely suit some places. Like these are very high density area. These are very high density area. This is like the capital area. Other than in those sort of places, don't actually, it's not going to be financially viable. It's going to be a white elephant scenario. So that's the danger of this sort of projects. We have to be very mindful. Don't just like, oh, China is doing it. Yeah, it's a Ponzi scheme. So this was my presentation on high-speed railway. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.